Section 1.5, looking at angles. Our essential question, how can you measure and classify an angle? So first we start by defining it. An angle is a figure formed by two rays that have the same endpoint. So here we have ray OA, ray OB, and the same endpoint of O. The rays OA and OB are the sides of the angle. The vertex of the angle is the endpoint, which is point O. Naming an angle, we have three basic things that we can do. If there's only one angle there, we can name it by the vertex, so angle O. If there's a number inside that's not a degree, this one is not 1 degree, right? It's just a number for naming it. We can name it angle 1. Or I can name it with 3 letters that define angle AOB or angle BOA. If there's more than one angle, you cannot use angle O, because then you don't know what angle you're referring to. So then either you need to use the number or the 3 letters. The 3 letters is the most useful, because if the angle's larger and there's something in between it, you might not be able to do the number. The measure of an angle, the measure of angle AOB, is equal to the absolute value of the difference between the real numbers matched with OA and OB on a protractor. Normally, for what we're doing, we will just have a number inside there, or math that we're doing to use it, so we won't use the protractor a whole lot. Oops, can't see that. But we will look at some problems with that. Then for the purpose of this class, we have 4 types of angles. The acute angle measures greater than 0 and less than 90. Your right angle is exactly 90. Your obtuse angle measures greater than 90 and less than 180. And your straight angle measures exactly 180. So those are our 4 types of angles. So looking at example of naming it here, example 1 says name 3 angles in the diagram, then name the vertex and sides of each angle. So when I'm looking at this, you can't use angle B. That's the vertex, but there's 3 angles at angle B. So you can't say angle B, you don't know what you're talking about. So you have to use the 3 letters. So if I'm looking at this top angle here, right, I would have angle ABC. The vertex being point B, and the sides being BA and BC. So these are my sides, my vertex, and my angle. Okay, our symbol for angle is the little, it's like a sideways V. Okay, so that is our symbol for angle. Then we have angle CBD. That still has a vertex of point B. This one, however, is made up of BC and BD, the rays. And then our third one is the large one, angle ABD. Right? Still has a vertex of point B. This now has a sides of BA and BD. So those are the rays that make that angle up. Then we have the protractor postulate. Okay, the protractor postulate says consider OB and point A on the side of OB. The rays that will form OA can be matched 1-to-1 with the real numbers from 0 to 180. basically this is saying that you can set up something like a protractor and then use it. Just like we talked about on the other side, the measure of that is equal to the absolute value of the difference. Okay, so the measure of angle AOB is equal to the absolute value of the difference. And again, most of us won't actually use absolute value because we'll just subtract the bigger from the smaller. Or say that backwards. Subtract the smaller from the larger. But if you realize you're getting a negative number, you subtract it the wrong way. So use absolute value then. So if we're looking at the problems here, it says use the diagram to find the measures of the constructed angles. So WSR is this angle here. Right? This is, and now there's two sides here. We have the 0 and the 180. You can work from either one, but be consistent. So if I start at 0, I'm coming up this way, I'm at 65. 65 minus 0 is 65. If I'm on the other side, I have 180. And I'm coming up, so you notice the numbers are going down. So this is not 125, it's 115. 180 minus 115 is still 65. TSW, I'm coming around the other way. So now I'm looking on this side. So now the numbers on the inside are going up. So this is 110, that's 115. The other side 0. RST, they don't give me anything where I'm doing real subtraction here, is 180. VST is 90 because it goes right through the 90. Looking at one that I would actually subtract here, WSV, right? I have WS, I have SV. This is 90. This is, if I'm on the outside, it's 65. If I'm on the inside, it's 115. So either way, when I subtract those, what am I doing wrong there? 90, 115. So I'd get 25. And that's what I'm looking at that angle. So this at WSV is the best example of the protractor postulate. I'd be doing like 115 minus 90, which gets me 25. Then looking at our next page there, right? Angle addition postulate, similar to the segment addition postulate. Now we're just doing it with angles. If P is in the interior of RST, then the measure of RST equals the measure of RSP and the measure plus the measure of PST. Okay. When we're referring to this going forward, we will use angle addition and postulate a lot as we go forward in class. We'll just abbreviate that to AAP. Okay. What we're saying is to find this large angle here, RST, I would add these two smaller angles up. And again, that's true of any addition postulate. It's saying you add the two smaller things to get the larger thing. Example 3. Find the indicated angle measure. So ABC, they give us 80 and 30. So when I add that, I'm going to get 110 degrees. Angle ABD. Now, here I'm not adding. They give me 60. They don't give, I'm looking for this part here. Remember, ABC is 180. So what I'm doing here is I'm doing 180 minus 60. So that gets me that ABD is 120 degrees. Angle bisector, again, bisect is cutting in half. So an angle bisector is a ray that divides an angle into two congruent angles. So it's cutting the angle in half. So example 4, in the diagram at the right, ray WY bisects angle XWZ, and XWY okay, which is this small angle down here, is 29. They then asked me for two things. I actually already have them down here. So XWZ is 58. I got that by doubling the 29. Both of these are 29. WYZ is 29 because these two are equal. And then our last sheet here, example 5, 6, and 7. Right, we have these same types of problems just with variables. The key thing here is how am I setting up the problem? And again, we see that over and over in geometry, that the issues people have in geometry is a lot of times not solving the problem, it's setting up the problem. Look for keywords. In example 5, it says in the diagram, BD bisects angle ABC, find angle ABC. So the key word here is bisects. Bisects means cut in half. That means our two parts are equal. So I have 2x plus 20 equals 4x. Subtract 2x from both sides. I have 20 equals 2x. X is 10. And again, watch what they're asking for. Here they're asking for ABC. Right? ABC is this whole angle. So 4x is 40. 2x plus 20 will also be 40. So ABC is 80 degrees. When I come down to example 6, now it says given that the measure of GFJ is 155, find GFH and HFJ. So here, nothing's bisected. I don't have something that's cut in half, but I know what the total is. I know what GFJ is. So here, I'm doing 4x plus 4 plus 4x minus 1 equals 155. So the problem looks very similar to the one above it, but it's different because of what they tell me. So I have a different setup, and that's one of the main things we need to pay attention to in geometry. So I combine like terms of 8x plus 3 equals 155. Right. Subtract the 3, and I'll have 8x equals 152. Divide by 8. We'll get 19. Now, they asked me for both of these, so I'm going to plug into each of them. Okay, and unlike above, they're going to be different. So I have 4 times 19 plus 4, which is going to get me 80. And I have 4 times 19 minus 1, which is going to get me 75. Then our last example, example 7, given that VRS is a right angle, find VRT and TRS. So them saying it's a right angle means they're giving me the measurement. Right? Right angle is 90 degrees. So just like the one above, I'm going to add. So I'm going to have x minus 4 plus 3x plus 2 equal 90. And they could have just given me the picture on this because they do show me the box. That means this is 90 degrees. Right? But they also give it to me in words. So solving this, and combine like terms, 4x minus 2 equals 90. Add the 2 to both sides. 4x equals 92. So x is 23. And then again, they asked me for VRT and TRS. So I'm plugging in to find both of those. So 23 minus 4 gives me that this is 19. And 3 times 23 plus 2 gives me that this is 71. If I want to double check my math, and I can do this on all three of these, I want to double check my math. 71 plus 19 gives me 90. 80 plus 75 gives me 155. Right? And here they both came out equal. All right? So that's a good, not a perfect indication, but a good indication that I did everything correctly. That is the end of the notes for 1.5.